Almost everyone loves sports, especially cricket. What if I say that there is a commonality in the path of Dhoni's six from his signature helicopter shot, Jacob Srigraham's pitching ball, John Embiid's classical shoot, and Messi's chip goal, or the path of a ballistic missile? If you're getting confused, worry not, children, as you are not alone. The answer is simple. All follow the path of a projectile. Sounds interesting, right? To start with, what is a projectile and why should we study about it? In simple terms, a projectile is any object in motion after being thrown or projected. If you are in the habit of throwing a pebble into the lake, the path of the pebble is a projectile. Thus, the concept of projectile is so dear to our day-to-day activity. Studying about it has become imperative as it provides the basic understanding to learn other complex concepts. To break the motion of a projectile, it can be imagined as to happen as a result of two motion components occurring simultaneously and separately. One component is along a horizontal direction. It has no acceleration. The other along the vertical direction. It has a constant acceleration thanks to the force of gravity. I hope you are smart enough to include the air resistance here. But let's assume for now that it has negligible effect on the motion of the projectile. Galileo added a feather to his cap by becoming the very first person to state the independency of these components. We have now learned the glimpse of the projectile. It's time now to learn about its components. For a projectile thrown at a given angle, we should also learn how to calculate the maximum height of the projectile, the time taken to reach that maximum height, and also its trajectory. Now, let's do the math to study the basics of the projectile. In a projectile motion, the downward acceleration acting on it is due to the gravity after the object has been projected. Always note that throughout the motion, the x component of the acceleration remains constant and only the y component changes vertically due to its free fall under the influence of g. Hence, if you write a is equal to minus gj cap, or ax equal to 0 and ay equal to minus g, the initial velocity v0 has the following components. That is, v0x is equal to v0 cos theta 0 and v0y equal to v0 sin theta 0. From the first equation of kinematics, v equal to u plus at and also s equal to ut plus half at square, the previous equation is written with respect to x and y axis, and the following values of Vx and Vy are obtained. That is, Vx is equal to V0x plus Axt and Vy is equal to V0y plus Ayt. This equation, taking the initial position to be the origin of the reference frame, becomes x equal to 0 and Ay equal to minus t. The component of velocity at time t can be obtained as Vx is equal to V0 cos theta 0 and Vy is equal to V0 sin theta 0 minus gt. From the second equation, s equal to ut plus half at square, we derive the following equations of x and y. That is, x is equal to x0 plus v0 x times t plus half axt square and y is equal to y0 v0 yt plus half ayt square. Taking the initial positions to be the origin of the reference frame, x0 equal to 0 and y0 equal to 0, we get the equation for x as x equal to v0 cos theta 0 times t and y is equal to v0 sin theta 0 times t minus half gt square. It shows the position of a projectile at time t in terms of its initial speed v0 and the projection angle theta 0. Though these equations may seem complex, it can be easily understood by a rich imagination and calculative logic. By logic, at the point of maximum height, that is Vy equal to 0, and therefore the projection angle can be calculated as theta equal to tan inverse Vy by Vx, that equals 0. What is the shape of the path followed by the projectile? Eliminating the time between the expressions for x and y in the equation y equal to v0 sin theta 0 times t minus half gt square, we get y equal to tan theta 0 x minus g by 2 v0 cos theta 0 square x square. It is in the form of y equals ax plus bx square, in which A and B are constants, and also V0, theta 0 and G are also constants. Wait, you must have studied the equation somewhere. Do you remember? It's the equation of a parabola. So what is the path of a projectile? Yes, you are right. It's a parabola. Now that we have deduced the shape of the path of the projectile, let's find the time a projectile takes to reach its maximum height. Let's ask ourselves, how much time does the projectile take to reach the maximum height? Let this time be denoted by Tm. Since at this point Vy equal to 0, we have from Vy is equal to V0 sine theta 0 minus dTm equal to 0, or Tm is equal to V0 sine theta 0 divided by G. By logic, if we substitute y is equal to 0 in the equation, the total time Tf during which the projectile is in flight can be obtained as Tf equal to 2V0 sine theta 0 by G, where Tf is known as the time of flight of the projectile. We note that Tf is equal to 2Tm, which is expected because of the symmetry of the parabolic path. Maximum height of a projectile, or the maximum height hm reached by the projectile, can be calculated by substituting T equals to Tm and using the equation y equal to ut plus half at square. By substituting the values of time to reach the maximum height and velocity in y direction, we get hm is equal to V0 sine theta 0, V0 sine theta 0 by G minus G by 2, V0 sine theta 0 by G the whole square. Therefore, the maximum height of the projectile is given as hm equal to V0 sine theta 0 square by 2G. Now that we have deduced the formula to calculate the maximum height of a projectile logically, let's move on trying to deduce the formula to find the horizontal range of the projectile. Based on a graph, to find the horizontal distance traveled by a projectile from its initial position to the position where it passes y equal to 0 during its fall is called the horizontal range, that is denoted by r, or it is the distance traveled during the time of flight Tf. Therefore, the range r equal to V0 cos theta 0 into Tf, or we can write that the range r is equal to V0 square sine 2 theta 0 by G. This equation shows for a given projection velocity v, r is the maximum when sine 2 theta 0 is maximum. That is, theta 0 will be 45 degree. That is sine 90 degree equal to 1. The maximum horizontal range is therefore Rm equal to V0 square by G. We have reached the final part, and now the range of the projectile launched with velocity V0 at an angle theta 0 is given by R equal to V0 square sine 2 theta 0 by G. For angles 45 degree plus alpha and 45 degree minus alpha, 2 theta 0 is 90 degree plus 2 alpha and 90 degree minus 2 alpha respectively. The values of sine 90 degree plus 2 alpha and sine 90 degree minus 2 alpha are the same, which is equal to cos 2 alpha. As a result, the ranges are equal for elevations that exceed or fall below 45 degree by alpha. Let us summarize what we have learned so far.
Manorama Horizon. Learning made simple.